welcome to our Julia for Introduction to Julia for High Performance Computing course. My name is Alex Wiens. With me is also Xin Wu. We are from Paderborn, from the Paderborn Center for Parallel Computing. And we are very happy to be here at the University of Cologne. With this iteration of our course, we were already in Düsseldorf last time, so we're very happy to be here today. And also happy to hear some welcome words from Professor Wesner from the ITCC from the University of Cologne.
Yeah. Thank you. So, hope that's good enough. Okay. So good morning, everybody. I found Julia is actually something that was coming up some years ago and was kind of a niche programming language where people thought, well, I can use MATLAB, I can use Fortran, I can use other languages, but it's come a long way. But now I think Julia is really getting in the focus of the attention of many people. Even engineers give up doing their prototypes in MATLAB and start them from Julia from scratch already. Many courses in the that had been teaching in parallel computing, maybe MATLAB or other things before mathematics here, for example, they changed their topic also towards Julia. So it's really kind of a language that really gained a lot of attention. And so it's quite nice to see that so many of you and also online are interested in that topic, because I think efficient programming is one of the key challenges that needs to be addressed. Should be easy, should be fast, and I think we will learn a lot in the next 3 days and how to do that with this with Julia. So, and also you will have the opportunity, as I've seen, to visit the most beautiful high-performance computing system in Germany. As we say, it's not the largest, but I think it's really a nice one. And before the question comes up, yes, you can make photos in front of it. Yeah. And someone will explain to you all the hieroglyphs and all the kind of symbols on the Egyptian letters on it. And that's actually one of the key benefits we had here in Cologne, because we really had someone that knows about Egyptian hieroglyphs and signatures and all that symbols, that's not saying something stupid. So it should be also valid something about the research area here. So it's happy to be here and maybe some kind of logistics. Well, there's the meeting room. There are some restrooms over there, just on the right side, and also in the corridors going up and down, so that you don't have to queue up. There's a little bit of coffee there, so maybe it's now a good time to grab one, not interrupting the lecturers later on, and have a nice 3 days.
Thank you. So you will find the course repository under this URL. Can you see that from behind? Is it maybe? Maybe like this. So for the on-site participants, we will also have our exercises, and you also got credentials. And as you see here in our timetable, we will have alternating presentations and then these hands-on slots where you can then get some hands-on experience with Julia, the topics that we're talking about. Then we have our breaks and the lunch break, and also today the HPC tour. And else, I guess, about the repository. if you go there, you will find a setup guide for a local Julia installation for your outside people. We have a Jupyter Hub on our cluster in Paderborn, where you can use Julia on the cluster via the Jupyter Lab with your credentials. We will see it in a minute. And we have here all of the slides and examples with the notebooks and the exercises and so on. So this is all of the material for the course and also the timetable again. Now the first thing is a little motivation about else if you have any questions, you can always interrupt me. It's absolutely no problem. And we wanted to start with a little motivation. Okay, so this course, we want to learn about Julia. We want to learn about HPC. It's Julia for high-performance computing. So it's just not a pure Julia course, but it's always in the context of high-performance computing. So we are from a high-performance computing center, and we want to teach you about using Julia in this HPC context and have fun some experimenting and see how far we can go. So this is like a slide. Julia in a nutshell. It's great on the domain science, from a domain science perspective. It has a very comfortable syntax. It's a dynamic interactive. It's a rich package system, ecosystem, and all the bells and whistles that you would expect. And on the other side, on the HPC side, it's quite performant by utilizing the LLVM toolchain. It's well equipped for parallel computing. You can use hardware, and everything is even interactive. Now, back in the days, there were two sides, the experiments and the theory. For the theory, you would just have your pen and paper and then do some hypothesis, predictions, and so on. And in experiments, then you would get in the nitty-gritty, dirty real world and do your experiments and then check your hypothesis. And nowadays, we have like an in-between thing. We have computational science. So now we can use computers to do all kinds of things for a lot of disciplines, engineering, natural sciences, social sciences, and so on. You can do simulations, modeling, analytics, optimizations, and so on. And however, for this, also there's an ever-growing need for higher performance for your computations. You have even larger problem spaces. You're doing more with your data, with even more data, big data applications. Therefore, to satisfy this need for performance, you try to use parallelism, so splitting up your computations to have them run in a reasonable runtime, improving data access, having cleverer algorithms. And traditionally in HPC, you would use Fortran and C, these nice, comfortable languages. So these have a high performance because they're close to the machine and they have minimal abstractions. However, they have a lack of productivity. And now we have Julia, who's trying to bridge the gap between more general dynamic languages like Python, where you can do some prototyping, but they're rather slow, and the production fast languages as C and Fortran. And this also means that it's easier to bridge the gap between domain science and HPC and allowing domain scientists to produce performant code and utilize HPC systems. And with Julia also comes a rich ecosystem of packages for different domains, chemistry, algebra, optimization, and so on. Therefore, Julia is a nice spot for different kinds of fields. And it's also accomplishing to scale very well. You can create some code that runs well on your laptop up to a HPC cluster and then scales over maybe even multiple nodes. Now, topics for our course is we start with a quick Julia refresher, because for some of the things you need good understanding of the features of Julia. Then today also Shin will talk about why Julia is able to run so performant. We'll look at optimization and performance code in the single-threaded case, multi-threading, parallelization over multiple nodes, and finally also using GPUs. In Julia, there's also the Julia parallel community. So these are people from HPC systems that are interested in using Julia on these large systems. So there are workshops and conference meetups, so you can find it online and have a lot more information in this kind of domain. There's also a monthly Julia HPC call. And now is a little bit time to introduce ourselves and do a little bit advertisement for us. So I'm Alex Wiens, this is Sean Wu. We are HPC experts from the Paderborn Center for Parallel Computing, and we are researching and teaching HPC and using Julia. So Paderborn, so this is maybe you know Bielefeld is a little bit south of Bielefeld. We have a nice history, founded in 1991. Our Paderborn Center for Parallel Computing, we are a research institute where we research parallel computer systems. We have our compute cluster so it's tier 2 and tier 3, so for people from NRW, but also from complete Germany, and doing our consultation and services. And we are well connected in HPC NRW, where also this course was organized from, and we are an NHR center. A few words about our system. So our current production cluster is the Noctua 2 cluster. So this is our rather new building with our cluster. So this is with 1,000 nodes and some NVIDIA A100 GPUs. And one focus of ours are also FPGA accelerators. And I can already tease you on our new cluster, which is not production ready yet. We are still working on making it operational, setting it up. And there we have more recent hardware with the recent AMD EPYC CPUs and NVIDIA H100 GPUs. And everything connected with low latency, high bandwidth network, and the high performance storage system. And we have a rather efficient system with water-cooled hardware. How to get access to our systems? For this, you have to, if you want to calculate on our systems, you have to do a little application on our application system. You have to decide on how much resources you need, what kind of type of project you want, depends on the resources and the length of your project. Then you fill a little bit of paperwork out, and then in a matter of days, you can get access. One focus of our center is chemistry and physics. So we are also part of the NHR Atomistic Simulation Center with Erlangen and Berlin. And so we have experts in quantum chemistry and physics. And maybe if you know someone who's also doing this and is using CP2K and GROMACS, we have an upcoming course on these programs in Paderborn. So maybe you can tell your peers about it. Another focus, as explained, are FPGAs. FPGAs are another kind of accelerators. I mean, everyone knows GPUs, but FPGAs are a type of chip where you have these logical blocks where you define what kind of logical function you want to have them executed, and then you connect it to the routed and connected to the I/O and some other blocks. And this way you can have very customizable computations on this chip, and everything runs in parallel. And we also try to combine this with Julia. We have this XRTGL package that makes it easier to access these FPGAs and the runtime from Julia. So it's also nice how Julia tries to connect to all kinds of existing projects and interfaces. So that's it for our little introduction.